So today, I want to talk to you about these mini splits and some helpful hints with them and some problems you might run into. So right now, it is 50 degrees outside, and we have this set at 82, and the thermostat, it's actually the remote, it's called Follow Me. It's 73. Probably turn that down. All you have to do is the up and down arrows on here. Turn it down to 77. Okay, it's at 73 right now. Now, one of the things is in the wintertime, when this starts up, it's going to take anywhere from 30 seconds to a couple of minutes. And if you haven't used this from air conditioning it in the summertime, it could take like up to 10 minutes. So, and you might even get an error like F1 up here where the display of the temperature is. And don't worry, if you haven't used it in like 3-4 months, it'll work. It's just got to balance the system out and everything. And when it gets down on this aux brand right here, AUX, when this gets down close to 32 to 34 degrees, it might not fire up and work. You might have to get up to about 34, 35 degrees before it'll start working. And there's actually a temperature sensor on this outside unit. Over right here, there's a temp sensor unit right there. And if you get an F1 air, you might want to check this. You might have to clip this thing off here, right? And then pull that tubing out a little bit and clean that and see if that is having a problem. If it's really dirty, it may not sense it. The other thing is I'm going to need to blow this out with the or vacuum it out or something, but be careful with these fins. You don't want to bend these fins when you do that. Right now, that unit is running that mini split over there. Now, this aux brand is good. It's your bottom of the line product. They're about $550, $600. But I tried using this upstairs, and where those refrigerant lines go in is the bottom of the floor. The top of that screen up there is where that thing is mounted, right above that door wall. If you can see that up there, it's right above that door wall on the inside, evenly between the middle of it. Now, the problem I had with the aux when I tried to run that up there, because you can see I'm running it down here, and that's probably about 10 to 11 feet, but then it's going up another 7 feet. So it's like a 16, 17 foot run from the ground here all the way to the head unit up there. And the problem I had was this aux brand, 12,000 BTU, 110 volt, doesn't have the head pressure in the compressor to push that refrigerant up. And you can't do that. So if I wanted to use this upstairs, up there on the balcony on the other side of that railing, I would have to put it up on the balcony up there, and then it would only be going up 7 feet to the head. And I could go in this wall, or I could go in the wall over there. So either way, but now this premium brand right here, this was like $150 more. This had no problem with the head pressure on it getting all the way up there. And The other thing I noticed was the Wi-Fi will work with this, but I could never get the Wi-Fi to work on my phone app with this aux brand. It just never, I played with it probably 30 times, could never get it to work. So they're okay for an area of like 400 to 500 square feet, an open area. So what I mean by that is, oh, Roxy, our solar pup, running out to the lay in the sun and get warmed up. Okay, so right now this is blowing out heat, and this is blowing pretty much straight down on the floor. So it's blowing onto my feet about 6 feet away from this down. And if you try to move this up, it'll eventually, after maybe 30 seconds or so, shut down and reset. So when this is facing down, it blows the heat on the bottom towards the floor directly from the mini split, and then heat rises. As where air conditioning, when the air conditioner's on, the air conditioner will be like this, blowing it straight out because cool air will drop on you. Now, this is what I'm talking about in open space. So I have this mini split, and this will cool or heat this entire space over here. And this is probably like 12 to 14 feet over here. And it is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 37, 40, 43, 46, probably about 48 feet run going that way. And that'll do well in that. Now we have this premium brand over here. And once again, you can see that the fin is facing straight down. Now this is a better unit. It'll cool 600-700 square feet. I have this one over here, and I have 18-foot ceilings here, and it goes all the way over. So this is, I believe this is an 18 by 28, and it's 18-foot ceilings, I believe, in here. So this heat's just blowing out. The air is blowing down here, and it heats up this whole area over here. So I have these two mini splits. They're both 12,000 BTU. And this big open area here is all heated or cooled. No problem at all. Now, if you're trying to do like a bedroom that's like a 10 by 12 or something like that, it'll have an easy job at it, but you're really oversizing. You might be better off with a 9,000 BTU. Now I have the same aux brand out here. It's 110 volt, 12,000 BTU. It's the same one as over the back door. And this is a 3-car tandem garage, and it's close to 600 square feet, and it'll do a good job heating this in the winter because I'm producing a lot of heat with these inverters over here, so that's helping. Right now it's not even running, and we're at almost 70 degrees in here without that even running. We've been running that one in there since 6 o'clock, and it's almost noon, and it's just now getting to 70 degrees in there. So kind of a benefit having my stuff in the garage. Really don't need to heat it, but I can kick that on. This one does really well in an open space like this for heating, but for cooling, it's not so good. I can't get away with cooling this. I can only get down to maybe 80 degrees with this in this open area, 600 square feet. So that's why I say it's like maybe 500 square feet these are better for. And it's a 12,000 BTU. Now this is an 18,000 BTU, 230 volt. This can heat or cool the entire garage. So I usually just run this one by itself. Originally I put this one in, found out it wasn't big enough for the summertime at 115, 118 degrees, but this was. So the other thing I wanted to show you is, if you're gonna do this yourself and you've never done it before, you're gonna have to buy a gauge set like this, and you'll get a red, a blue, and a yellow line. You'll get the gauges right here, and then you're going to need a oh, there it is. It's already on my blue line. That valve will fit on the outside low side of the inverter, and you'll have to open and close this in order to be able to get the refrigerant to go in there if you have to add refrigerant. But you'll also need one of these vacuum pumps. And actually I got the vacuum pump, the case, and the gauges like 3 years ago on Amazon for like 150 bucks. And it's probably not that far off right now. I'd put a link on there, but they probably don't even have these brands on there anymore. But the one thing I wanted to stress to you is I bought this stuff. It's called Nylog Blue, and it's kind of if you can see that, it's a little clearer. The longer it sits, the darker it gets. But I used this on the threads of the outside unit. When I was putting any, like right here, when I connected the line set right here to the head unit, there's a high side and low side. Low side's the big line, high side's the little line. And I put the Nylog Blue on the threads here before I put it together. And been around 4 years, and I've had no leaks with anything yet. So it really works good. The Nylog Blue is, you always have vibration from the compressor and the fan running. So what that Nylog Blue does is it seals those threads, and with the amount of lower pressure that you have on this compared to a regular heat pump or air conditioner on your house, it's thick enough. It's almost like a honey when it comes out, and it's real sticky and thick. And it keeps the refrigerant from getting through the threads and leaking out on you. So it covers you on the threads where you connect here and you connect outside. So I really highly suggest it. It's maybe like 18 to 20 bucks a tube, but one of these, I had enough in one of these bottles. I don't know if you can see that. Let me put my cheaters on. I had one in there, enough in there to do like 3 or 4 mini splits. That is a 30 milliliter bottle, and it's gasket and thread sealant, compatible with all refrigerants, will not contaminate system. So don't have to worry about that. And like I said, you need these, but now Signature Solar has some new units where you don't need any of this equipment, and I don't believe you need this either. And so they'll save you, $150, $200 if you don't need to use this. You might want to go and check the links in the description, and I'll have some links for, I think they have 9,000 and 12,000 units right now. But the other thing that you'll need to keep an eye on, like every 6 months, if you live in a real dusty area, it might be once a month or once every 2 to 3 months, you might want to check. But on these units, right up here, you have a temperature sensor. It's right there. You need to make sure that that's clean, and it's right around that. That's probably about 3/4 of an inch away from that screen. And that's a temperature sensor there. This right here is for if you wanted to use Bluetooth for your phone. I've never got it to work. I've got the Bluetooth, but I've never had them work for me at all. I couldn't even get them to hook up. But you have these 2 screens in there, and I just took this out the other day, and I ran these underwater, cleaned them off. Just be very careful. I dry them with a microfiber towel, and then I put it back in up there. You just gotta push it in and push it up over there. Push that piece, and that piece, and press it down, locks in. So you got 2 of those screens right there. You want to change those out or clean those, and all you got to do is press on this, press on that, and it closes it back up. These are the microfiber cloths I got. I think I got these at Costco. They're just microfiber. They come in many different colors. I have these. I have some blue ones down here, but I just use the microfiber ones instead of the cotton towels because they don't leave lint on there. So, but this one, like I said, is 110, 120 volt. This is 230. So I can run this off the 6 kilowatt, 12 kilowatt. But this is those are dual phase, 120, 230. And these are only 120 and 120, so I can't run them off of those. And then I also run these, right now, I'm running the outside 3.5 ton off of the battery bank down here. That's actually a full-size air conditioner, or heat pump air conditioner that came with a house, and that's heating the upstairs. Now I use that because I have bedrooms. I have 4 bedrooms upstairs. One's a master with a bathroom and bathtub and shower and everything. And then the other one is a full bath, and then there's a loft up there. So there's 5 rooms plus a bathroom, 6 rooms up there in the hallway. And a mini split's not gonna do that. If you have a split head where you can put in like 5, then you could put a mini split in each one of the bedrooms and you'd be fine, because the cool air from all those going in there would cool down that bathroom as well. It might get a little warm, but I've never used one of those multi-head ones. This one, there's 3 of those EG4 5120 volt, 100 amp hour, 5120 watt hour lithium iron phosphate batteries in parallel down there for a 15.3 kilowatt hour battery bank. And that's running that, which runs the mini split in the living room, 12,000 BTU, and the one upstairs that's 3.5 ton. So this one, these 2 batteries here in parallel, which is a 10.2 kilowatt battery bank, lithium iron phosphate, or LiFePO 4. That is running this 120 volt inverter, and we're running that one over the patio door going out by the pool. So we actually have 2 mini splits going downstairs, and we have the upstairs 3.5 ton whole house heat pump heating upstairs. Now I actually have 1, 2, 3, 4, 5. I have 4 inverters. That's an inverter, off-grid, inverter, off-grid, inverter. This is just a charge controller, and then this is an inverter. So I could parallel this one to get split phase. I need 2 of those. Or I could parallel this one and I could also get split phase. And one of the things about these mini splits, like the aux one over here, is I can manipulate this. Earlier I said if you do that, it'll shut down. But see, it's at that angle right there. I could actually put it like up about 3/4 of an inch. And remember, hot air rises, so you want it to drop. So right around there, you can see that the leaves, it's actually hitting the leaves. So by manipulating that and pressing that up 3/4 of an inch, and that's about all I can do, it'll actually blow down here and blow towards the floor. And as it does, it's rising towards the ceiling. So we have the, says it's 68 over here. And this is what we said, 46 or so feet from wall to wall. And 68 over there. And it's 71 right here. So, you know, to go that 46 feet, that's not bad. So you can have it like that. I wouldn't suggest running the fan because over here, the fan is just gonna make it go in this room and it's not gonna be able to blow through that way to the rest of that long room. But like I said, these 12,000 BTU mini splits are great for these big open areas up here. And once again, the heat will rise up here, there, and it'll go into the hallway over there. And we're heating that, remember, we're heating that up there with a 3.5 ton. So this is a 1 ton, 1 ton. So we have 2 1 tons downstairs and a 3.5 ton upstairs. And that's vented to the bathroom, the loft, and the 4 bedrooms, also into the bathroom, shower area of the master. So, you know, these work really well in big areas. But if you're trying to, if you have a 3-bedroom upstairs, you can't put it in 1 bedroom and expect it to cool or heat the other 2. It's just not viable. That's where you would need, where you have 1 outside unit, but then you have 3 of these head units, 1 in each one of the rooms, and they have an individual remote that you can use in there. And each room could be different. 1 could be set at 65 degrees, 1 could be set at 70, and 1 could be set at 75. They can be totally independent of each other and run off of just 1 outside unit out there. So, but, you know, it's, like I said, when I started running this one, I went like 3 months without running air conditioning or heat. And all of a sudden I went to go run this. And it was actually about 32 degrees outside and I got an F1 on it. So I took and cleaned the screens. I cleaned the temperature sensor on the inside unit, the outside unit, fired it up, but I realized I had to get above 34 degrees outside for this aux to actually work for me. Now, the premium brand down here, I actually got this a couple years ago. It was down to like 22 degrees and it's still fired up and heated up. So much better brand. You're not gonna have, I have no issues. I don't think I've ever had an error code on one of these premiums, but I do get the error codes on there. So, you know, if you haven't run it in a couple of months, you might get some error codes and you might have to unplug the unit, turn it off, unplug the unit or turn the breaker off on it if you have it hardwired and let it set for like 10, 15 minutes and then turn it back on and try running it. Now, if you didn't use that Nylog blue and you didn't tighten down your refrigerant line fittings, you could have had some of your refrigerant leak out and that'll give you an error code as well. You'll have to look in your owner's manual to see what error code it would be for low refrigerant. But like I said, if you use that Nylog blue like I did, and I didn't use a torque wrench or anything like that. I just tightened it down where it was snug, and I've had no leaks whatsoever in any of my mini splits. And I have 7 of them. I have 2 in the downstairs, 2 in the upstairs bedroom, 2 in the garage, and 1 in the motorhome. And the one in the motorhome works really good. Well, we're going to be installing this inverter in there. It's a 48 volt. All these are 48 volt. And then the 48 volt, it's actually called a 5120 volt, 100 amp hour, 5120 watt hour. I got 2 of these EG4 LLs coming to where I'm going to put those in the motorhome. So that'll be 10.2 kilowatt that'll be able to run this. Now, like I said, this is for up to 4, 5, maybe 600 square feet, depending on how well it's insulated. The garage is really well insulated, so it heats really well. But for some reason, it just cannot get those temperatures cold enough in the summertime to cool the garage. And, you know, I've got it right here, so it's got a good 15 feet over this way, going this way towards the garage door. It heats up a little bit. There's a little bit of metal exposed on there. And then you have almost 15 feet going towards the tool bench over there. And this thing blows straight out. So, you know, it's not going to be a real even heating and cooling in here. You know, if I had it over here, I could get away with it, but the garage door opener's pole's in the way, so I can't mount it there. And besides, the association would never let me mount it there. I could mount it on the inside if I had more room there, run the lines inside over the wall behind the gate, and then they'd never see it. So, but that way, that would blow from here towards that way, and I'd probably get a little better. Now, one of the things on these cheaper ones is this piece right here, this vent. You can get this to cycle where it opens and closes like this and keeps cycling like that. And you can get that to work on that. But on the cheaper ones like this Auxin Premium, this in here, these vents there's some vents in there, those don't move. Those you have to manually push. See, you have to manually push those to get those to move. But on this 18,000 unit Hessier, these fins up there that are inside there, you can see the fin right here and right there. Those fins all in there, they do have the option where it pushes the air back and forth like this, even if it's going up and down, even if this is opening and closing. That's kind of a nice feature in a room like this where you have it mounted in the middle. It'll blow up and down, and it'll blow both at the same time as it's working like that. And that one I got like 3 years ago at Home Depot for like $1,000 for an 18,000 BTU, 230 volt. So I really like that one. But they actually have much more efficiency. I think, I want to say this is a 20 SEER, as where this is maybe a 16 or 17 SEER. I think the Premium is an 18 SEER, and Signature Solar has like 22, 28, and once in a while they'll get in some higher ones in the 30s for the SEER. The higher the SEER, the less wattage you need to run that unit, and the colder the air coming out of it. So definitely, like I said, that's like a 16 SEER, and this is maybe a 20 or 20, maybe 22 SEER. I can't remember. but it definitely blows out much colder air than this thing does. And this blows much more force air coming out of here. So, you know, you can put this in like those rooms over here. If you wanted to, the house came with 2 3.5 tons, one for downstairs, one for all this area. And it came with a 3.5 ton upstairs and downstairs. I actually have a 4 ton downstairs I never use anymore because I use these mini splits. These 2 mini splits use half the amount of watts as the heat pump that came on the house. And when this reaches temperature, it will slow down in the watts and go from maybe 800 to 1,000 watts while it's heating or cooling down to maybe 300, 400, 500 watts. Now, my main air conditioner, once this thermostat reaches the temperature desired that you have it set at, it just shuts off the air conditioner or the heating. And the problem with this is I had to put a soft start on these things on the upstairs and downstairs to get them to work. This one pulls 119 amps startup surge on the amps. And I got it down to like 32 to 36 amps by putting a soft start on it. Now, when these things start up, they start up at like 20 watts. There's no surge on them. It'll go like 20 watts, 40 watts, 45, 60, 80, 100, 120, about that fast. It's no surge. When this whole house air conditioner heat pump kicks on outside, it's instantly calling for, it was calling for like 119 amps on the 4 ton and 78 amps on the 3.5. Now, this one was calling for, when it went to start, it was like 119 amps surge. And the 3.5 ton over there was like 78. That's down to like 20 to 22 startup amps. This one's like 34, 36. Now, these right here, these only use like 10 to 15 amps on that one. This one over here uses, you know, the high peak is 10 to about 13, 14 amps, depending on how hot it is. The hotter it is outside, the more amps you're going to use and the more watts it's going to need to run this. This starts up when it's cold in the morning. We don't run our heater overnight in the wintertime, even if it's going to get down to 30 degrees, because it's only there for like 1 or 2 hours. So it's like 64, 65 degrees when we get up in the morning. That's not bad for us. We don't mind that. So then I'll turn on the mini splits or this upstairs heat pump, and this only uses like 16 to 1800 watts when it first fires up. And after it's been running about 5-10 minutes, it'll go up to like 2000 watts, but it'll stay kind of like 2000 watts heating or cooling depending on the time of the year. And so that's pretty much close to like 2000 watts. This is like 26 to 2800 watts. This is a pool heat pump. It's a heat pump, but it's for the pool water. That'll use like 7,500 to 8,500 watts. It's insane. 1,600 to 2,000, and I think it's like 22 to 2,800 watts. This is like 1,000 watts, and if it's 115 degrees out, it might go up to 1,200 watts. And this is like 1,000 watts, and if it's 115 degrees out, it might go up to 1,300 watts. But they don't go over 15 amps, so you can wire these into regular circuits or plug them in. Like me, I ran this flexible conduit out of all these in, and then I either ran a plug on it. Like this one right here doesn't have the flexible conduit. It's actually a 10 gauge extension cord, which this calls for like a 14 gauge So this 10 gauge is more than enough. And then I have it over here, and that actually is plugged into the outlet on the wall right here. So this is, it's getting yellowed from the sun when I have it out on the sun's getting to it. But it's I can plug this in anywhere. And actually, this is actually my grid, and this is actually solar, and this is solar. And those are my AC disconnects for my big air conditioners for the downstairs. That one's a solar, and that is the grid. And then this is for solar down there for the 3.5 ton, and that's for the grid for the 3.5 ton. So I either have it, I have one fuse pull in there, and it's in the solar on both of these. So the fuse pull is in that one. There's no fuse pull in the grid one, and there's no fuse pull in the grid one. So I would have to take the fuse pull out of the 4 ton and put it up here, or the 3.5 ton and put it there. So, but they're pretty easy to do, DIY. The mini splits, I did those. I put the soft starts on the 4 ton, the 3.5 ton, and that's a 12.7 ton pool heater. I put the soft starts that I got from Signature Solar. I'll put a link in the description. I installed all those myself and reduced all those down. Oh, I was going to show you one last thing. So we have a bunch of different solar arrays. Right now, there's 6 panels there, 6 panels there. They're both in series. And then when I bring them together, I parallel them to come into the house. I have solar panels up here that I can only use in the summertime. There's 24 of them up there, and I'll have 6 in series, parallel that, and then 6 in series, parallel those two. So I only have two solar panel lines going in. Here's one, and here's the other one. So you can see right there, you got 2 red and 2 black. So for 24 panels, I only have 2 wires going in. And this is for our motorhome mini split. Over here is the other, that's the one in the living room, that premium brand that's 12,000 BTU, 110 volt. And here's that aux one in the garage. It's 12,000 BTU, 110 volt. And then that is the Hessier that's 18,000 BTU, 230 volt. You can see the difference in it. This one's probably not quite twice the size, but much more efficient than this little one. But, you know, if you have a small house that's in an L shape like mine or whatever, it's open concept, you can probably get away with 2 of these mini splits. I would go with the premium over the aux. These are, never had a problem with either of the 2 premium brands I have. Never error codes or anything on them. Never leaking. So I would recommend these. I like the aux, but they do come up with error codes, and I can never get the Wi-Fi to work on my phone. Just the sticks that they send you, the USB sticks they put in there, they don't work. Although these work well. So, like I said, that's a 1200 watt solar array. There's 12 100 watt panels on there, and that will be for the motorhome. And that's where I would go boondocking and set this up, and it takes me less than an hour to completely put it together and then to tear it down. And then we have a pergola here that has 4,000 watts on it. And I don't use all these at the same time. I use them for different projects, what I have going. This is a 6,000 watt solar array. This one over here is 330 watts times, so it's like close to 2,700 watts. Then I have 250 watt panels, 6 of them, 3 on this side, 3 on this side. I got 3 over here and 3 over here. So these are 1,500 watts on those, and those are in series, 3 of them in series, 3 in series, and then the 2 are parallel together when they come in on the wires right there that go in that flexible conduit and go into the house or into the garage. So we've got a bunch of different arrays that we mess with, and we can move them around pretty easy. And this other array over here is 14 solar panels, so that's 250 watts. So that's 3,500 watts on this solar array over here. This gets eastern exposure in the morning. And these are those are 250 watt used panels. The back wall is 250 watt used panels. The panels up above these pergolas, 250 watt panels used. And they're all polys. Those up there on that pergola, 16 of those. Got 24 there. Those are all used solar panels that I bought for like $25 to $40 a piece. I've had them for 4 years now. Those are all poly panels. All of those 250 watts. These are 100 mono panels, and these are 250 watt mono panels on these 2 sheds. And these are 330 watt mono panels over here on this array. So we got quite a few arrays going on. And then we have extra panels down here. We got 4 more of these extra. And we have some 185 watt. We got 5 of those. Those are mono panels. And got 2 over there that are for parts. They kind of blew off during monsoon. One's wire missing out of that. But I might use that to use drip line the 1/2 inch or 5/8 inch tubing and make a solar heater for the pool to kind of boost a little bit. So what I would do is I would flip that thing over. I would put that tube in a circle, like, you know, whatever way I can to make it the most tubing fit in one of those panels. And then I would take in, somehow put some metal brackets or something to hold that tubing in there, and then just set it on the ground. And when that sun hits that solar panel laying on the ground, it'll be like 180 degrees on those. They get like 180, 200 degrees when they're in direct sun in the summertime hitting those, or in the spring or fall. And that'll actually heat that tubing up really well. So I might recycle those solar panels that crap out on me. And I've only had two or three. And it was because of monsoon, and they ended up blowing off the roof because we had like 70-mile-an-hour winds come through. And they're usually like these end ones where the wind can catch it. And I didn't have them tied down at the time, secured down, so they just blew over. But at 25 to 40 bucks a piece, you're not out a lot of money. Now in the future, we're going to be looking at getting some new 400 watt panels with bifacial to where you could get up to 500 watts out of them from Signature Solar, and that's a project down the road. Anyways, just wanted to do a quick video. It wasn't that quick. It's 40 some minutes on these mini splits. And like I said, just to recap, if you get them, and I bought my mini splits off of eBay, but my next ones I'm going to be buying from Signature Solar because they have it where you can put it together without using any of this stuff. That saves me money. That saves me 150, 200 bucks. And they also have where it's direct connect to the solar with these MC4 connectors already attached to the outside unit. So you don't need an inverter and you don't need batteries unless you want to run it overnight. Then you could have the battery. You'd have to have the battery and inverter to run it overnight. But if you just wanted to run that mini split during the day off the solar, you could just buy the mini split and the solar panels and connect them. And you could actually put a cord on it if you wanted to and plug it in to a 110 volt outlet, like a regular grid outlet like this. Or you could hardwire it into, this is just solar in here, but on your house panel or your solar panel, whichever, you could either go into solar panel fuse box or you could go into the grid breaker box. So I like that you can do that, and that's really nice. I can use that in the house or the motorhome, and those are like 22 to 28.5 SEER or something like that. I think they have some higher ones, but last time I looked, those were the ones in stock, and they were 120 volts. And then I think they had a 24,000 BTU, but I'm not sure if that's a direct solar panel connect or not. But those are definitely nice. But now in the summertime, I have those three 5.1 kilowatt hours and those two. These are in parallel. Those three are in parallel. Parallel those together, and I run it into here, and I'll run that 3.5 ton upstairs where all the bedrooms are overnight, and I'll still have 30% of my battery bank left in the morning just running that upstairs, and cool air drops. So the downstairs stays cool. It never gets over 80 degrees downstairs, even if it's like 114 or 115 out during the day, and it's like 98 at night. It's still not running that air conditioner downstairs. Doesn't get really warm at all. Stays pretty cool. And we're going to be adding 2 more batteries to this, so that'll give us 35.7 kilowatt hours. So running our air conditioner overnight in the summertime, we'll probably have like 45% of our battery bank left over to use in the morning if we need to. And then usually these things in the summertime get charged up at like 8, 9 o'clock in the morning. They're 100% charged. And if I wanted to, I could even run a mini split downstairs and I'd still have like 35% left over, running one mini split downstairs and then the main 3.5 ton upstairs. So a lot of different things you can do with this. But if you decide that like you wanted to get one of those direct connect solar panels to the mini splits, if you just ran it during the day, you can expect to cut your electric cost, depending on how big it is and how much of your house you're trying to cool down. I was able to cut mine 40 to 50% each month, just running it during the day and then switching over to grid at nighttime. So definitely the daytime is the hottest part. You're going to use the most amount of electricity. And it even, as I got it tweaked in, I even got to 65%. I cut off my electric bill just running those mini splits overnight. And then when I got to the point where I could just run that one 3.5-ton air conditioner overnight on my solar battery bank. Solar during the day, solar battery bank at night. That knocked probably about 80% off of my, 85% off my electric bill. And I run my pool pump 24 hours a day, 7 days a week, pretty much 365 days a year. And this spring and fall, I'm heating my pool off of solar. So solar has a lot to offer. These are all off-grid. These are considered low frequency, so these will start up big things like 3.5, 4, 5-ton air conditioners. Those will not. Those are 120 volts. And even if they were paired together with another one, they don't have enough in there. These have really heavy coils. This is 109 pounds. This is 186 pounds. And this one over here is like 22 pounds. This charge controller is like 18 or something pounds. And this thing's like maybe 30, 35 pounds. So huge coils in those things. And that's the only thing you can start those big air conditioners or pool heaters with. You cannot do them with these smaller ones. These are considered high frequency and these are low frequency. So I hope that helps you. Like I said, we have 1, 2, 3, 4 inverters and a charge controller. Then we have a just a 124 volt inverter that's 12 volt DC to 120 volt AC right there. So we have a lot of wires running over here, but we're always messing with moving our arrays around to see what we can do with what we have and trying to test the limits on a lot of this stuff. So it is a lot of wires, but it's all pretty much the same on each one. So you have your battery bank comes out of your inverter into a DC breaker, and then out of the DC breaker it goes to bus bars, and from the bus bars it goes down to the battery banks. And on these, all these, I have Anderson 175 amp quick disconnects connected to connect up my battery. Like over here, my battery is connected from here, and this goes right there. This part goes up to this, or over to this bus bar, and then up there. Then you have, I have this coming down out of the AC out, coming into this outlet. You got your 2 MPP charge controllers, one here and one here. I'm only using one right now. And so I have a DC breaker on each one of those arrays to shut down that. And if you look right here, this breaker right here will shut this down right here. So if we turn this breaker off and then go look over here, see how quick that shuts that off? So that breaker shuts it off pretty quick. We'll turn it back on. But that's pretty much the same thing, except for this. We have the battery cables, negative, positive coming out, and then we have the negative and positive coming from our solar array. This is going in to our charge controller, and this is going out to our battery to charge our batteries. And this one over here is the only thing that's different. This orange cord is a AC in, so I can actually, if I don't have any solar on this, oops, I could actually take this plug and plug it in right into that one, that outlet, and then you'll see that, see that circle flashing on there? In a minute there'll be a bar going over to my battery, and that'll say that the solar is on. And maybe not, because I'm at 56 volt. Oh, there we go. So it's charging with the solar and the grid. So, but my grid is actually my solar. So, but I do have it long enough to run over to go into my grid power over here. So a lot of stuff there. So it's a lot of wires, but you have 5 independent systems in here. Actually 6. You got the inverter. It's just an inverter. It's not, you know, you have a charge controller here. You have an inverter there. That's a 12 volt and that's a 48 volt. So you couldn't pair those together. They wouldn't work. So pretty easy doing these. I never knew anything about mini splits or solar or electricity before I started this. And I was able to do all this just watching videos from YouTube channels like mine, trying to explain what to use, where to use it, what size to use, and be able to get everything to work. And we've had really no problems. Every once in a while, we get some parts on some of the things. The only problems I had is those Evo batteries down there. The breakers are not the greatest on there. It's over here somewhere. There it is. Okay, so this breaker, which probably had no more than 30 amps on it, going through it, because it's only was on 48 volt system, and I usually used it on this one, which is only 120 volts output. So you know it's 6,500 watt, but I usually run no more than 2,500 or 3,000 watts out of that, the max. And this is a 250 amp breaker, 48 volt for 48 volt, and that thing just melted the crap out of that. So that breaker's crappy, and I think the BMS in there doesn't really work that great in order for that thing to fry like that. So I actually had to use a breaker that I got through that came, a 48 volt breaker that came with this, a DC breaker, and I actually put that in down there. So that fixed the problem. Got another one right here. The other problem I'm having with this is all these say 13.1 and 13.2 volts. This says 12.9, but when I hook up a meter to it, it's 13.2 volts. So BMS isn't the greatest. I wanted to really have those work. They advertised at the time I bought them that you could take those 4 12 volt batteries, put them in series and make 48 volts, but you cannot. They won't work together. They might work for like 6 months or a year, but then they'll start having problems like the breakers doing this on you. So I wouldn't recommend them. If you're going to use them in 12 volt, maybe, but still, they're rated to go down to 10.5 amps. And the other day, I was running this mini split. So these are rated to go down to 10.5 amps each. Or, I'm sorry, 10.5 volts each. And when one of these batteries drops to 10.5 volts, it cuts them all. It shuts down your inverter. So you could have 12 volts, 12 volts, 12 volts, and this get down to 10.4 volts, and it'll shut shut this one down. This breaker will go off, and it'll shut it down. And so it shuts down. You no longer have 48 volts. You have 36 volts. That'll shut down your inverter. So you can't even get the 10.5 volts. These over here are rated to go down to 20% of the state of charge, and I've gone down to 24% and everything was still running. Big difference in the quality and the performance and dependability on these versus those. In fact, they don't even advertise you can run those in series anymore. You can only do those in parallel. So they don't even sell a battery that you can series together anymore, only parallel. So really disappointed in those. And those were around $2,000 for 4 of them. And you can catch these on sale for $1,300 a piece. So these are a much better value. So pretty much it. Please like, share, subscribe. Don't forget to hit that notification bell. We'll see you in the next video, and we hope you have a truly wonderful and extremely blessed new year in 2024.